Listo.
Hola, muy buenas noches a todos. Estamos aquí para una charla con Rogelio, que es el fundador de Open J Proxy, el cual es un proxy gratis, open source, para nuestras aplicaciones Java o incluso otros lenguajes. La charla va a ser en inglés, yo voy a ser el traductor. Yo soy miembro del grupo Java de Barranquilla y el del grupo ACM en la Universidad del Norte. Estoy aquí acompañado también con Giovanni Mendoza, también miembro del grupo Java Barranquilla, y con Michael Ruiz Díaz y con Betsy, que ahora se van a presentar. La charla va a ser en inglés y cualquier pregunta que hagan en el chat, pues yo voy a ser el responsable de traducirla. Ok, entonces podemos empezar la charla. Okay, Rogelio, you have the floor. You can start your presentation now. And any question that pop up in the chat, I'm gonna translate them to you. So you can tell them who you are, what you do, what is OGP, sorry, and all of that.
Thank you. Muchas gracias, Laureano. I appreciate the opportunity to be here tonight, and I really would like to thank the guys for organizing this and for being here, for me translating, organizing the event, advertising it. This is very important for open source projects like ourselves. Like the Java user groups have been a big support for our project, and it's a pleasure and a privilege to be here with you tonight. I'll speak a bit slow, try to make my statements very clear. If there is questions or misunderstandings, people can put it in the chat. Laureano will be helping maybe to translate something in real time, even though the presentation itself cannot be in Spanish. Hopefully in the future, I'm Brazilian, I should know Spanish, but I need to go back to classes. So if that's okay, I'll start presenting. I have a few slides to present. I'll share my screen. Just let me know when you can see it. Is it visible?
It seems yeah, it is visible, but there seems to be a problem. Betsy, can you hear me, or you just can't hear the? Can you hear Rogelio?
I can hear. I can hear. All right. Yeah. Can you hear me?
Yeah.
I'll try to present again.
Yeah, I'm sorry. It's something with Betsy here.
Okay.
You can continue.
So, should I try to present again?
Yeah.
Okay. Just 1 second here. Let's see. Is it visible now?
Yeah, it is visible.
Okay. Yeah, so the presentation today is about the Open J Proxy, as mentioned before. I'm the founder of the project and the lead developer. So this is the agenda for today. We're going to cover this, so I'm not going to stay in this for long. There's a legal notice. Basically, it's just to say that if you use these materials, I'm not responsible for how you use it, but you're free to use anything that's presented here. You can copy, you can use in your own presentations. Just don't hold me responsible for how you use it, obviously. Just a quick mention to our partners at the Open J Proxy. We have the Comunidad Brasil JUG, another Java user group, which was the first to give us space and to help us to start building the community. Switcher API, which is a feature management platform that you can turn on and off features at runtime in production. Meterian, which is from a Java champion that is our partner as well. It helps you to make your code more secure. It looks for vulnerabilities in open source code. CyberJar is a YouTube channel. If you're not following CyberJar, follow now because very good content, very sharp content in relation to Java, only focus on Java. Java's Challenger is another channel for career development. If you're looking to develop your career, that's the place to go. Amazing content for free, and also sponsored. If you wanna have mentorship, they have mentorships as well. But the free content is already killer. And Omnifish is the people behind the Eclipse Glassfish. So they are our most recent partners, and they are helping us to build the Open J Proxy. So these are our partners. They're very important to us because they're helping to build the project. Now, starting off, just a reminder in relation to how computing systems work, right? So anything that uses central processing units or CPUs, they have a limited capability of doing parallel work. So what that means is that if you put too many threads to a limited amount of CPUs, what will happen is that those threads need to juggle between one thread and another. The CPU needs to pause one thread, save the state of that thread, move to another. So that juggling is called context switching. And what that means is that your CPU is using effort to switch between threads instead of doing real work. And that's important in relation to databases because databases also have this sort of limitation. It's not easy to nearly impossible to elastic scale a database. So you have a limited amount of processors to use, a limited amount of parallel capacity to use. And that's important for what we're going to talk next, which is the limited capacity to address parallelism by a database. So it comes from a fundamental limitation on the hardware first, but also in the database. Like if in the hardware we have limited CPUs, in the database we obviously have those limited CPUs, but we also have limited amounts of how many connections in parallel or how many instructions in parallel we can execute in the database without start losing performance, right? So a very quick example here in a stateless services example using Spring Boot, for example, with any database. In our example here, we start with a simple Spring Boot app that opens 20 connections to the database, right? And probably this Spring Boot app is running the standard Hikari CP connection pool, right? And it is opening 20 connections to the database. If this app needs to be scaled, let's say you have an elastic scale policy on this app, and it starts to scaling to 3 instances and then to 5 instances, you can see that the database is starting to get under pressure. That's because currently in most Java apps, we have the connection pool in the app side. So every time you create a new instance of that app, a new connection pool is created. And in our example here, if that connection pool has a maximum connection of 20, in the worst case scenario, you might have 20 connections from each of these instances hitting the database. And that starts creating pressure, in part because now the database needs to switch context between those connections and threads. And it becomes more prone to lock contention and all sorts of problems. In general, less connections to the database increase performance because the database has an easier job to lock things, and serializing things makes it run faster in many scenarios. There is well-documented evidence of that, even from Hikari CP, some interesting articles about that, and from Oracle itself. Now, in our example here, at the moment, we get 8 instances of this example app. Our database dies, right? Basically becomes unresponsive. And that probably, if you're long enough working with Java and you worked in many different environments like myself, you probably have seen this scenario, right? Where the database goes belly up. I didn't introduce myself. I leave it for the middle of the presentation just because or else the presentation is too slow at the start. So I wanted to start with the content already. I'll make a presentation about myself in a while. So once this hits this scenario where you have too many connections, you have the risk that your database goes belly up, right? That it dies, basically. So why we created OJP? So OJP stands for Open J Proxy. And what we wanted to do with OJP is that we wanted to scale our apps without overwhelming our databases. And we also didn't want to over provision our database because most apps, because they need to account for this scenario where you have a lot of connections, engineers tend to over provision the database. So we wanted a database that is the right size, not over provision. We also wanted something that is not bound to a specific cloud or a specific database, because we have solutions like the AWS proxy, but it only works in AWS, or the PG bouncer, which is a database proxy for Postgres, and it's very, very good. It's very well used, but it only works for Postgres. So we wanted something that could work for any database and that could work in any cloud. We also wanted something that is easier to scale, because currently the model that we have for database proxies, when you want to achieve high availability, you normally need to put a load balancer in front of it, and that puts another level of complexity on your proxy setup and your proxy topology. We wanted something that could integrate with Java apps easily. We wanted something that was fully open source, because not all solutions that we currently have are open source. And we also wanted it to be developed in Java, if possible. That was a question we had. Can we develop this in Java? As we are Java developers, right? Like, that's a fair question to ask. Also, we wanted to have a connection pool that is as efficient as Hikari CP, because Hikari CP is the standard of Spring Boot, and we wanted something as good as Hikari CP. And then this diagram came up. So the epiphany of Open J Proxy is basically summarized in this diagram here. So we created two parts, right, for the solution of Open J Proxy. One is the proxy itself. You see in the middle of the picture, and it runs Hikari CP inside it. So it's a Java gRPC server proxy, which runs Hikari CP connection pools inside it. So for the question, can we have something as good as Hikari CP? Well, if we are writing it in Java, we can use Hikari CP itself. And that's one of the great things about using Java to build this. Now, we needed something that could connect to our proxy in an easy way, and that we could integrate with Java apps seamlessly or in a simple way without the code change. So we decided to build as well our own JDBC driver. So when you're using OJP, you're going to be using our JDBC driver. And what that allows you to do is that you don't need a load balancer in front of the proxy anymore, because the JDBC driver will do that load balancing and failover for you. Also, the OJP server can support multiple databases, as in the picture. You could have Oracle, MySQL, Postgres, DB2, SQL Server, and CockroachDB. Those are some of the ones that we support. I heard some sound there. Is there a question? You can interrupt me if there is a question. If not, we continue. So the essential, the fundamentals of the, let me just double check. Are we still live? Are we good? Can someone respond just to make sure? I heard a noise and just want to make sure that's still live.
You are sharing the screen.
It's all good. Okay.
Yeah.
Okay. So we we proceed. The main concept of OJP is to create a limited amount of connections to the database. So in the example there, you see that there is only 10 connections to each database, and the apps are opening many more connections. So you can have as many instances of the apps as you want. Those connections open between the OJP JDBC driver and the OJP server. We call them virtual connections because they don't hold the real connections to the database. And in the OJP server, we use the real JDBC driver or the actual provided JDBC driver from each vendor. So if you're running Oracle, you're going to use the Oracle JDBC driver in the OJP server. If you're using Postgres, you're going to use Postgres. So you use the native JDBC driver in the OJP server, and you use the OJP JDBC driver in the client, or in this case, the Java application, right? So just by that, you already get a backpressure mechanism, because you can have as many virtual connections in front of the proxy as you want, but the real connections to the database will be limited and will protect the database. And what that produces is something like this, right? You can have the same amount of apps as before, the 8 apps with 160 connections, but OJP will keep a safe level, let's say 50 connections to the database, and keep the database happy, as in the picture. So that's the fundamental motivation for a database proxy, and this is the OJP solution for a proxy. We also think that OJP is a great asset and very valuable for the distributed monoliths. What is a distributed monolith? A distributed monolith is something that used to be a monolith, and that has started to be breaking down into microservices, but the database remains centralized. So it is some people consider it an anti-pattern, but in our experience, it's the reality of many companies that they manage to break down the monolith into smaller services, but the database is still centralized. And then you have like orders, billing, inventory, for example, as services, but still a single database, sometimes with different schemas, sometimes not. And if you put OJP in front of this database, again, it will help to decrease the pressure on the database and to make the reliability in general of this database better, because you're not going to have the overwhelming numbers of connections that you would have if you didn't have something like OJP in between. One quick comparison of OJP and existing proxies. So in terms of how many databases they support and how much open source they are. So you can see that the blue ones are open source. So you have options like PG Bouncer, Vitess, or Proxy SQL, MaxScale. They are open source, but they only support one database or a family of databases. For example, Proxy SQL is mostly for MySQL databases, or MySQL and MariaDB databases. And PG Bouncer, Odyssey, and PG Pool, only Postgres, right? And then you have the cloud solutions like Alibaba DB Proxy or Google Cloud Proxy that are partially open source, but not really open source, and they are tied to a cloud provider. And then you have the solutions that are completely closed, like the Amazon RDS proxy or Aurora proxy is called like that as well. And they don't support many databases. They support mostly the Amazon Aurora database, and they are not open source at all. So
sorry,
OJP is the only. Yeah.
We have a question from Michael.
Yep.
He's asking what's the difference between using HiCAN directly or using OJP?
Using what or OJP? Sorry, I missed it.
Between using OJP or using HiCAN directly?
Good question. Yeah, good question. So basically the difference is this here. If you're using Hikari CP, in this picture here, Hikari is sitting inside the Spring Boot app here. So when you're opening connections, you're opening connections directly to the database. So you cannot really control how many connections are open, because nowadays with microservices and Lambda even, or serverless architectures, you can spin up more and more nodes of the same service, right? But if your connection pool is inside your service, which is the case of Hikari CP inside Spring Boot app, those connections start piling up. And that can create what we call a connection storm, because let's say you have a Black Friday and then the connections spike, your database is not prepared for that, or if it is prepared, it's over provisioning. It's completely over provisioned. So on one side, if you don't over provision your database, you might be a hostage of a spike on demand, and that spike on demand increases the number of connections you need, and that can bring your database to a state that is unresponsive or very slow, right? Another scenario is when you're under a DOS attack, a denial of service attack. If you don't have something between the app and the database, also a large increase on demand can bring your service down. So the main difference is where the connection pool sits, because in this figure here, the connection pool sits inside the application, and in this one here, it sits inside the OJP. So you move your connection pool, because we use Hikari CP, right? So it's the same connection pool. It's just instead of the connection pool being inside your app, we move it to a server separated from your app, and there is only one connection pool then, right? And that can centralize all the management of connections and the flow to the database, protecting the database. That's why we use a shield as our logo, because the main idea is to protect the database. Does that answer the question, or?
Yeah, I think it did answer the question.
Yeah, if you have other questions or if you need more clarification, please feel free to interrupt me, and we'll make this a conversation, right?
Sure, thank you.
Right. Thank you for that. So yeah, this about this slide is just to show that OJP, nothing like OJP existed, right? OJP is the only proxy that is really database agnostic. It's the first one that attempted to do this, and the first one that is fully open source as well. Just 1 second. Going forward, these are just some notes. So the proxies is a layer 7 proxy. It's implemented in Java. What that means is that we don't just send packages here and there. We are not a layer 4 proxy, which would be a network proxy that would be just pushing TCP packages here and there. We understand what we are receiving. We can read the SQL. We can evaluate. We can do more things than a proxy layer 4 can. That comes with a cost. Obviously, we're slightly slower in principle than a layer 4 proxy. But also because we do it in a more intelligent way, and we can evaluate more things than a layer 4 proxy could. So that let's say, a difference in performance can be shortened. We are still testing performance for OJP, but the first result seems encouraging. I'll show you a few results, but there is some caveats on the results we currently have as well. So I'll let you know what those caveats are. We already talked about everything that's in this page. We are actually creating what we call a control plane capabilities on OJP. So it's already more than just a proxy. Even though the name is a proxy, we don't just do proxy with OJP. And one of the good examples is what we were talking before. How can you do high availability, right? AJ in traditional proxies, you can see there on the left. So you have your application that needs to talk to a load balancer in front of your proxy cluster, and then your proxy cluster talks to the database cluster. So there is 1, 2, 3 bridges in connection, right? three hoops in the network before you get to the database. And that obviously is not ideal. And mostly that is caused because the current proxy model is tied to the wire protocol of the database. So nobody ever attempted to do the way we are doing it, which is to deliver the client as well as the proxy. So we deliver them together. And by doing that, we can do what is in the right side of the image there, where the application has our OJP type 3 JDBC driver. And that driver connects to the OJP servers that are not labeled there, but are the blue boxes in the middle. And those servers talk directly to the database. So you decrease one hoop in the network. You don't need a load balancer or some schema with the VIPs in front of your proxy cluster. Your JDBC driver is the guy that will choose the healthy proxy to send the request. It will load balance between them and fail over if one of these proxies goes down. So OJP has capability of being deployed in cluster, and it has capability of failing over and load balancing with the JDBC driver. So the JDBC driver does that job. And that creates a bit of a, let's say, less expensive environment and less complex for operations because you don't need to manage your load balancer. If you're in cloud, that's not a lot, right? It's just provisioning a load balancer, but that incurs in costs, even though not operational costs for you directly. OJP can also be deployed in bare metal, doesn't need to be deployed in cloud. So it's very flexible.
Okay, we have another question, a very interesting one from John. He's asking if because of the many services if because of the many petitions from the many services, is it possible that Open J Proxy gets overwhelmed, or does it get to a point where it cannot handle that many petitions? And if that's the case, how can we handle that?
Very good question. Yeah, it is possible. Like any computing system, it's possible that it gets overwhelmed. But you need to calculate what is your expected demand, right? Now, it is a lot more difficult to overwhelm OJP server because it's basically a gRPC server, right? And if we go back to what a gRPC is a protocol that was developed by Google and is largely used by Google. So when you use Google services, it's basically using gRPC all over the place. And this protocol and the way it works, it's very efficient. So we have a gRPC server running in the OJP server. By default, that can take 200 connections, 200 threads simultaneously. And if it gets more than that, it will kill them. So it creates already a backpressure mechanism, and it will not let it kill the server. Of course, if there is a large attack on your system, that can be increased. But the main thing you can do to avoid OJP servers going down is first provision the right amount, because there is no limit. You can provision. We recommend at least 3, right? That you install in production with 3 OJP servers. But you can, if your demand is bigger, you can provision 5, 10, 20, as many as you need. Or you can provision less with bigger resources. And then instead of starting it with 200 threads, you start it with 400 or 500. You need to do testing, performance testing, right, for your use case to assess what is the best setup. But we recommend at least 3 OJP servers, and that would be like 600 concurrent jobs being executed, and that's quite a lot. So for a scenario like this that we showed here with 8 instances of the application, that probably would be enough. But depends very much what you're doing and what is your capability, how much you want to scale your application, right? Does this application scale from 5 instances to 50 or from 5 instances to 10 instances? And then you need to do an assessment of what is the maximum capacity you want to tolerate. So to answer shortly the question, it is possible to overwhelm the OJP server. It's not easy. I would say it's very difficult to overwhelm the server, because it's also a very lightweight proxy, right? So it doesn't do much work. It basically passes through the heavy work to the database. It's more like a gatekeeper. So if you receive like 50 connections at the same time and your limit is 20, or in this case you receive 160 connections at the same time and your limit is 50, you just organize them so they go in a queue, right? In a serial form. I won't say queue because there is no queue implemented, but serialize them and send them one by one to the database. And the database is the guy that actually does the heavy lifting. So I would be surprised if the OJP is the thing that gets overwhelmed in the system. Probably what you're going to have is that your app may get overwhelmed first, because that's the one receiving all the load, right? OJP will just queue the requests. They might get slower, but to break a gRPC server, you need to make a large effort. It needs to be really a DOS attack. And if you have a limit for your app, for example, this app just grows to 20 instances, you're going to have already calculated how many instances of OJP or the sizes of the OJP servers you need. So the likelihood that the OJP server will go down is very, very little. I hope that answers the question. If there is anything else, I can talk more about it. Another cool thing of using gRPC is that gRPC uses the protocol buffers, right, or the proto buffers. And what that means in short is that if you want, you can use Open J Proxy with other languages than Java, because as we provide a proto buffers contract, a proto buffers API, you can in principle compile that to any language that supports proto buffers. Just a few examples here, like C++, PHP, Python, Ruby, C#, Golang, that's not here, but other languages, right? You can compile and create your own client for it. Now, it will not have all the capabilities that we provide in Java, because our client is a very evolved client already. Like I said, it does load balancing, it does failover, so you would have to implement those capabilities. But to implement some basic functionality for a simple access to the database and to use OJP server as a proxy, it wouldn't be that complicated. You could achieve that quite quickly. To have the full functionality that we deliver with both our server and JDBC driver, that would be a lot of work for sure. But maybe in the future, we're going to implement ourselves some clients for these other languages if there is demand for that, obviously. At the moment, we are more focused on Java. But the fact that we use proto buffers allow us to think like, okay, if there is a lot of people in C#, for example, that are interested in using Open J Proxy, we can create a client for C#, implement full functionality for C# as well, or any other language that supports proto buffers. Moving forward, we have a built-in circuit breaker in OJP. And just quickly explaining what that means, if you're not familiar with a circuit breaker. The green lines are queries going to the database. If everything is good, they keep flowing to the database. The circuit breaker is fully closed, right? It's sending all the queries to the database. If one query starts failing repeatedly, the same query starts failing repeatedly, what the circuit breaker will do, it will trigger and will block that query. So if a query starts to fail and doesn't stop failing in a period of time, the circuit breaker will block it by default for a minute, and then after a minute, it will send one request of that query to the database. And if that request fail again, it go back to blocking it for another minute, and then sends again a test query or a test execution of the same query to the database when it's requested. And if it succeeds, it comes back to normal performance, right? So we have this built in OJP, so you get it for free. You can enable or disable it. It comes enabled by default. So if for example, you start receiving timeout errors when your system is under a lot of pressure, the circuit breaker will trigger on the heaviest queries. It will fail them fast, and that might be the little breathe you need to give the database to recover from something that would spiral into a catastrophic event if you didn't have this sort of protection in front of the database. So OJP shows its best features under stress. It's something planned and made for applications that need to support a lot of flow, a lot of stress, and sudden stress as well. So it should recover faster, it should stress less the database, and keep the stress into the OJP server.
Okay, we have questions.
Yeah.
Okay, the first one is, I think it's something that you already talked about, but you can clarify. What's the difference between using OJP and a utility like PJ Bouncer?
It's essentially a similar approach, right? PG Bouncer, the main difference is that PG Bouncer only works for Postgres, right? So let's say you have a situation where you use two databases, you use Postgres and Oracle. I worked in companies that did that. They use Postgres for more internal applications, for applications less sensitive, and Oracle for their more transactional, more client-face applications that they needed more robustness. So if you have two databases, PG Bouncer only works for Postgres, right? So you would have to have two operationals. You need to have people specialized in both of them. So the main difference, I think, is that OJP is database agnostic. And another difference is that once you need to scale the proxy, we can just scale our OJP JDBC driver will manage to load balance between this cluster of proxies. If you use a PG Bouncer, you're going to have to do what is in this left side here. You're going to have to use a standby proxy with just two deployed and a virtual IP in front. Or if you want to have more than one proxy, like a cluster, you need a load balancer in front of it with VIP as well. So it's simpler in our evaluation for Java applications to use OJP. Also, you can use it with multiple databases at the same time with the same proxy, which you cannot with PG Bouncer and Proxy SQL and these other proxies.
Okay, thank
All
you.
right.
We have another question.
Yeah.
From Giovanni. He's asking, can we use these proxies metrics to determine the optimal size for a connection pool?
If you can use the proxy metrics to determine the optimal size for a connection pool, not directly, but we implement very good telemetry with OJP. We are actually expanding the telemetry that we export. Just now there was a merge of tracing into Open J Proxy. What you can do is you can test your application under stress with and without OJP, and that will give you an idea of if you need OJP or not, first of all. And then to size your connection pool, the best approach I see is that you should have a performance test that tests the maximum capability or the maximum capacity you expect in production. And then you should calculate how much is the maximum capacity you intend to have in parallel, how many transactions you want to have in parallel. And there is a calculation I can share with you. There is a CyberJar video exactly about that, how you calculate the connection pool. And you can start with that. Like an older way to calculate a good connection pool is by how many CPUs you have. Let's say you have 8 CPUs in this database server. So a good start would be to start with the number of CPUs plus a few connections, right? So 10 connections, for example, for real parallelism. But that's a very old thing. It doesn't account for modern systems. So the best way nowadays is to calculate how many parallel threads you want to address in the database. And there is I can share later what is the formula for it. You start with that, and then you execute your test of performance, right? Because that is just a guide. The formula is just a guide. And once you start with that, you execute the same test with the amount that the formula gives you, and then you can execute the same test with less connections or more connections and compare results. And then you're going to have, okay, like this is better to reduce or better to increase in relation to what the formula gives you. I can't remember the name of the formula, but in the CyberJar is a recent video that they did that they actually mentioned Open J Proxy as well on how to do this connection pooling calculation. It's a very good video. So basically, it's related right to how much you want to take through the database. Just as an example, like Hikari CP by default, I think the default is 10 connections. So it's very low. Like some people put 50, 100 connections without doing any calculation. Normally, less connections with the database is better. Of course, it depends what you're doing. If you're doing some application that is to do fast investment in stock market or that needs high throughput, maybe you cannot even put a proxy because you cannot afford the extra network hop. But for all other scenarios that are more balanced, like online shopping or this and that, then surely putting a proxy and using the centralized connection pool will give you advantages in relation to not having one.
Okay, thank you very much. There are a lot more of questions, so I'm gonna just ask you one more, and then I'm gonna let you continue for a while, and then we continue with the questions. That's okay?
Yeah, sure. Fire ahead.
Okay. We have one very interesting question from Betsy. She's asking if we have already some applications that are working in production, what are the criteria or the requirements that we need to think about if we want to use OJP in those applications?
Very good question. So the first criteria is if it benefits from controlling the amount of flow to the database, right? So that's the first question you need to ask yourself. For example, if you have a small application that serves very few clients or customers, that might not pay off to put something like OJP in it. OJP is best suited for applications that have elastic capabilities. So you have an application that can grow from 2 to 10 instances or 2 to 20 instances suddenly. That's not to say that it doesn't give benefits to even fixed setups. It depends on testing, right? So if you look at your application and you feel like, oh, this application has many instances, but I'd like the number of connections to the database to be the one that I set, because I calculated and I know the best number of connections to the database after watching the video I mentioned. So you set the best possible maximum number of connections to the database to a number that the database will be able to do the work and that will not be overwhelmed. If you need a gate that controls that and that doesn't let one application or multiple applications breach that limit, then OJP is a good candidate for your application. If you're out of, there is two extremes where OJP is not good. If you're small and there is no chance of that being ever used by too many people, probably it's not worth to put Open J Proxy, except if you're doing this for your own learning purposes, right? You want to develop with Open J Proxy because you want to learn how it works, then great. Or in the other extreme is the situations where you cannot have the extra hoop in the network, like you cannot put the proxy in the middle. For example, when you have fast transactions like payments or trading in stock marketing, that those kind of scenarios that the nanoseconds matter, then probably OJP is not the best, but then no proxy is good in those scenarios, right? Because you cannot afford the extra hoop in the network. Again, you would have to test that, but everything in between is probably a good candidate to use OJP. Any more questions before we move?
Yeah, we have more questions. Would you like to answer more questions? Would you like to answer more questions, or would you like to continue the presentation for a while?
I'll continue a bit longer, and then before the demo, I think I have just 2 more slides before the demo, and then before the demo, we answer a couple more. We do the demo, and then we answer more later. Can we do it like that?
Yeah, sure. Okay.
So in relation to performance, we did a few performance tests. They are very preliminary and like they need to be improved. We currently have someone writing a scientific paper for OJP that will test it better with more scientific methodology. But we did do some testing. We can see here that with very raw conditions, like when I say raw, I mean not using a connection pool at all versus using OJP with connection pool, right? So we can see that with OJP, the database used a lot less CPU, and that even the average response times with OJP improved. But that's not what we want to deliver. Like average response times is not a great test, so we want to do better tests in relation to this, especially because when you're not using a connection pool, the database suffers more to open and close connections, right? So there is a bit of noise in these tests, but it can give you an idea that how it protects the database. So it surely decreases the amount of pressure to the database immediately. And in some cases, it might even improve your response time, especially under stress. That's for sure. Like we noticed that as you put more and more stress to the database, if you have a centralized place for the connection pool that keeps the flow to the database stable, the database performs better. We can answer a couple more questions before we do the demo. The demo is about how to put OJP in a Spring Boot app. So if there's questions in relation to that, we're gonna cover them.
Okay, thank you very much. So the first question we have here, it's from Sergio. He's asking, what are the key techniques or features that Open J Proxy uses to increase the performance of Java applications, like improving resource management, stability, or scalability?
Can you repeat the question, please?
What are the key techniques or features that Open J Proxy uses to increase the performance of Java applications?
So the key techniques are related to controlling how much flow goes to the database, right? So if we come back to this screen again, So the main feature is, doesn't matter how many connections you open before OJP, right? The real connections to the database are controlled, and that keeps the database happy. And the database is one of the things that cannot go down, right? Any instance of your app can go down. Like nowadays, you have Kubernetes that will provision a new pod, will put a new instance of your app, will keep your cluster healthy. But the database, if the database goes down, everything goes down, right? So the main feature that OJP delivers is this protection to the database. And by that, when we say that it improves performances, it's mostly related to reliability, I would say. It increases the reliability of the overall system. And that shows more when it's under pressure. OJP does a better job when it's under pressure. Because if there is no pressure, any solution works, right? That's the reality. Like if you have just a few users accessing your system, that any solution will be good. So I think the main characteristic of OJP is that when pressure starts raising, OJP holds that pressure and doesn't let that go into the database, and the database keeps doing its work like nothing is happening, right? So even if you are in a Black Friday or if you're under a DOS attack, from the database perspective is a business as usual, right? It receives a steady flow of requests. That stability is the main feature that we are trying to deliver here. Stability, I think, is the key word and the key feature we deliver with the Open J Proxy. Any other questions?
Yes, the next question, I think you can answer it during the demo. It's from, okay, I cannot read that name. I mean, I don't know how to pronounce it, but the question is, if we have a regular Jakarta application server, if we want to use OJP, do we create a connection pool to OJP the same way we do with any other database?
Very good question. And it will be covered in the demo. So let's do the demo.
Okay.
Yeah, let's go for the demo. So what I'll show you here, this is a demo app that we have in our integration tests. We have a repository in OJP that is just for testing these integrations. I can quickly show you actually before we go into them. Apologies, I should have closed a few of these. So if we come here to the Open J Proxy organization, to the repositories, there is one repository here that's OJP framework integration. This has no OJP is this repository. This is our website. This is the frameworks that we test every time we commit to the main branch. So we have a test running against Micronaut, Quarkus, Spring Boot with Atomicus, Spring Boot with Narayana for XA validation, distributed transactions, right? And Spring Boot. So for this demo, I'll use this Spring Boot app. What that is basically a ordering app, right? So you can create orders, you can create order items, so all that sort of things. So we have integration tests here. They run against the H2 in-memory database. So this is your common Java Spring Boot app, right? So if we come here and see the structure, you have your controllers here, right? Orders, order items, products, reviews, users, very common setup, right? So your VOs here, like your entities, and your repositories, right? Probably if you worked with a Spring Boot, that's a setup that you know very well. Now, let me just delete this because I had to reverse engineer, right? So I removed OJP from this so I could show you how I put it back, right? So at this point, it doesn't have any OJP mention. So it's just connecting to two data sources. And you don't need to use more than one. You can use just a single data source, which is the easiest to implement OJP. But just to show that OJP supports more than one data source, we left this example with two of them, right? So how we're gonna do the demo? We're gonna run these tests without OJP, and then we're gonna run OJP server, and we're gonna modify this app to use OJP. So the tests are running, right? The order item integration tests run. They use the H2 in-memory database for the tests, and everything worked. So if we go to our repository again here, and we just follow the steps that are there, just open in the main page. So if you come here, like the first step is to start the OJP server, right? So to start here, there is just one caveat here, because we are already talking about the version 040 beta, which is coming out next month. That's why it's already in the main branch. But currently we have released only the version 032, which doesn't need this step here that you download the drivers and put it and mount it into a directory. But if you do it like this, it's gonna work anyway. So that's why the documentation has been updated already. What happens is, because OJP server uses the real JDBC drivers, in the previous versions we were packing it with the open source versions, but that was making it too heavy. We didn't know which versions the user want to use, so we decided to remove it, and we created this OJP libs that you can put your drivers in there, and then OJP will recognize them, load them into the class path, similar to what Tomcat does with the WebInf, right? Like it's based on that idea. You can put your Java jar files in there, and then OJP will load them up in memory. So if we get that, let me just see here, clear. Let me just move this a little bit, because it's always in clear. More clear. Docker PS. Let's see what's running. If it's already running, I'll kill it so I can show you. So OJP server is not running. Okay, good. So what we're gonna do, what I did here is that I created this demo Spring Boot folder. Inside this folder, I created the OJP libs. So mkdir, right? OJP libs. And just before the demo, inside this OJP libs, I put the H2 jar, because it's the one that we're going to use for the demo. You could put whatever you want here, right? It could be Postgres, could be MySQL, Oracle, whatever database you're going to use for your application. Now, we're going to use this command exactly as it is here, and that will mount this OJP libs that I have locally here into an OPT OJP libs inside the Docker image. At the moment, this version, we're not going to use it, as I mentioned, but from the next version, if you don't put it there, it's not going to work, right? So it's worth to do it like this. Okay, Docker PS. Let's just make sure it's running. It's there, it's running. Docker logs. And let's just take a look at the logs, make sure it's healthy, right? By default, it runs with only error logs. The fact that it didn't show anything is a good sign, because there is no errors. That's what it means. You can decrease the log level, right? We have documentation in relation to do that, but the images come with error only for performance, right? So less log, better performance. Now, you can also run it as a runnable jar. There is documentation here in relation to how to do that, but we're going to use the Docker for just because it's easier for the demo. It's faster. So now in your app, what you're going to be doing in your app, the first thing is that you need the JDBC dependency, right? So you're going to be adding a dependency to our app. So in here, we can find a place to put the OJP dependency. Let's just load it already. The second step in the app, third step in general here, we're going to be changing the URL to use a prefix. So let's say if we were using Postgres, all we need to do is to, just after the JDBC column, we add a prefix, which is the OJP location. In our case, is localhost, the default port is 1059. So that's basically what we're going to be using. I left a little helper here because I need to do it for two. So because we have two data sources, we also going to be using a named data source. So this is for the first. So if we come here to our application test of properties, we're going to find the high performance data source. We're going to add the OJP prefix to it, right? So what this is saying is that it's saying, I want to use OJP as my proxy. The location is this location. So you're going to connect to the OJP server on this location. And this between brackets is a name for a data source. It's optional. So we're going to have one named high performance, and the other one doesn't have a name, which means it's the default one. So we're just going to put the OJP URL prefix. You don't need to change anything else because that will be used by OJP to connect to the real database then. Username, password, all stays the same. Now, here we need to change, right? Because we're not going to be using the H2 driver anymore. We're going to be using the OJP JDBC driver. So let's just copy it from here, from the documentation. And that's basically it. Now, in this page here, it doesn't go into detail on how to do this in Spring Boot, but we have extra documentation. If you want to see specifically for Spring Boot, there is this page here, Get Started with Spring Boot, Quarkus, and Micronaut, that speaks specifically about Spring Boot. And here there is a few extra steps for Spring Boot. And I'll explain you why do you need to do that. Basically, for example, here, when we put OJP JDBC driver, and we're going to be excluding Hikari CP from the app. I think that was a question there, like how do you create the connection pool in the app? You don't create, that's the answer. You just remove it completely. You don't need a connection pool in the app anymore. So it's one less thing you need to worry about. But because Spring Boot started comes with the Hikari CP by default, we need to exclude it, right? We just need to remove it. So that's what we're going to do next year, just before we finish with the application properties. So if we find the Spring Boot starter JDBC, we're going to be adding an exclusion. Sorry, I shouldn't delete. An exclusion here. We're going to be excluding the Hikari CP, right? And that I left a comment there, like when using OJP proxy connection pool, the local pool needs to be removed. And that's because you cannot have two pools, one trying to pull connections from another. Like it just gets messy. So our application doesn't have a connection pool anymore. And now we're going to finish the application properties, right, for this test. We already have the prefix. We already have the driver. There is just one or two more things here. I think it's just one more, actually. We just need this for Spring Boot, which will tell Spring Boot that we want Spring Boot to use a simple driver data source. That's because when you remove Hikari CP, it doesn't have a data source anymore, which means it cannot create connections anymore. So you just need to set the simple driver data source. Whenever a connection is needed by the app, it will create a new connection, which in OJP is a virtual connection, so it's super cheap to create. And when it doesn't need that connection anymore, when you finish your transaction, whatever it is, it instead of returning to the pool, it closes the connection. And OJP uses that close call to send a signal to the server and say like, okay, I don't need this connection anymore. You can use that connection for something else. So for the app perspective, is opening and closing connections. But from the OJP perspective, those connections are virtual and they are cheap. Let's just make sure that we use the same. You see here, we need to use the same Spring pattern, because in Spring, the name of this this configuration is catalog. We gave a name, right? We don't need to, but it has a name. So you just need to be careful. If you did give a name, you need to put the name also in this guy, in the data source type. Also here for the checkout, so we're gonna put the same line after the driver, and instead of catalog is checkout. And you see that we didn't use the same names, like Spring name is catalog, but for us it's high performance, right? So we gave a different name. Now, where does that name that we gave for OJP goes? That's the next question. Because we are using two data sources here for the demo, we're gonna have to create an extra file here, which is called OJP properties. And that's just because we want to set the configurations for our pools, right? So I have them prepared here. I'll walk you through what they are. If you're doing your first test with your app, you don't need to create this, okay? You just create your default connection pool. Sorry, your default configuration for OJP. You connect to it. It will use the default Hikari CP with 10 connections. It will work. You don't need to create the OJP properties for your very first hello world test. But because here I wanted to show that you can use a different data source name than the default. So you do need then to create the OJP properties, because you need to give a name to the properties, right? So this is the full data source. Those properties will apply to this guy here at the bottom, because this guy doesn't have a name. And now this high performance, we can find it here. So you just prefix the same properties with the name you gave there, right? So you see you gave high performance name for the data source here. In the OJP properties, you put whatever configurations you want here for Hikari CP. So maximum pool size, minimum idle, connection timeout. There's other connections you can use. And now let's go back to our documentation, just make sure we're good. Yeah, that's everything that should be done. Now we can run our test again with OJP now. So let's see. Oh, it's great when it comes green, because in some presentation it doesn't come green, you know, and then you need to search what went wrong. I'm kidding. Just in one presentation, this didn't work, and that was because I was using the wrong version of OJP server with the wrong version of the driver. They need to be the same, right? If you're using the 0.32 beta version of the OJP server, you should be using the same in the driver, especially because now we are still changing the contracts. So sometimes it might work with a different version, but we cannot guarantee. So just to show you that this is really going through OJP, what we're gonna do here is we're gonna kill the OJP server, right? And once we do that and try to run this test again, we should see it fail now. Yeah, it fails because it couldn't find, right? Unavailable. We cannot connect to OJP server. So this is the demo. If there is still a question in relation to how to put this in an app, please let me know. But basically, what you can do here is to check for this page here. And if you're using Marker, not Quarkus or Spring Boot, the steps are always here. But the steps are always basically three inside the app. You modify your connection URL, you remove your current connection pool, because OJP will take connection pool over, right? It will take care of it. And you add the OJP JDBC driver in your project. Now, in each of these frameworks, you might need to do one or another thing, like in Spring Boot, that you need to actually exclude the Hikari CP because it comes with the Spring Boot. And these steps are documented there as well. But in principle, like it's three steps from OJP's perspective: change the URL, disable the connection pool, and add the OJP JDBC driver to your project. All right. Any questions?
Yes, we have some questions left to answer. Okay, the first one. The first one would be does OGPay introduce any noticeable latency between sending the request and the ability and the does OJPay introduce any noticeable latency between sending the request and the response of the data in the database?
If it adds any latency, is that the question?
Yeah. Yeah, does it
absolutely.
add any latency? Yeah.
Oh yeah, it will add latency. Yeah. Whenever you use a proxy, using a proxy, not just OJP, right? If you're using a database proxy, it will add latency for small loads. But again, if you're under stress, even the response times improves. So under stress, you might have better response times than not using OJP. But in low demand, surely there is a little bit extra latency there. And that depends on how your network as well is set up, right? Where the OJP proxies, OJP's proxy server is deployed. Because if it is deployed in a different network than the database or than the app, that also creates an effect. So in general, like there is three ways to deploy OJP. You can deploy in the same network as the app, in a different network, in a third network for more security, but then more latency as well, or close to the database. So the communication between OJP server and the database will be quick, but from the app to the database will be a bit slower. But in any of the scenarios, it adds latency. If you send a single request, the latency may be double, right? Because those milliseconds that takes network or nanoseconds, that you cannot avoid. But that's not a characteristic of OJPs. If you're using a proxy, you need an extra hoop of network, right? One thing that OJP does in relation to that is to remove the extra hoop of network of the load balancer. Because if you want to use another proxy that doesn't have the capability that we have in relation to doing client-side load balancing and failover, you need a load balancer in front of it. So instead of having one network hoop, you have two more, because then you go from the application to the load balancer and then to the proxy. So that part we try to minimize. But latency, in normal conditions, you'll have probably bigger latency than not using OJP. Any other queries, or shall we continue? I cannot hear you if you're speaking. All right. Can you just confirm if I can continue with the presentation, just to make sure that there is still connection?
Hi, continúe.
Hey. Okay, okay, all good. One other feature that we introduced in OJP that doesn't exist in other projects is this low query segregation. And basically what that is that in a conventional connection pool, all the lanes, like in a highway, are shared by all queries and all statements. And some of them can be slow, like the tractors and trucks, and some of them can be faster, like the blue cars. But because the pool is shared by all of them, in one moment you may have only slow queries taking over the whole pool, especially in mixed scenarios where you have slow queries with fast queries all running in the same pool. So we created this system where we classify the queries and we divide the pool in two sections. So the same pool is divided in a section that we call slow query lanes and fast query lanes. So what that delivers is if you have slow queries and they start piling up, they don't take over the lanes of the fast queries. So you can always have the fast queries running through while the slow ones getting processed. Because as we said, we want usually to have less connections, but by having less connection, you might be susceptible to having slow connections, slow queries taking over your entire pool, and then all queries are waiting for those slow queries to finish. In scenarios where that is a possibility, we implemented this feature. It's called slow query segregation. It comes from the version 0.40 beta. It will come disabled by default. Until now, it was enabled by default because we wanted to test it more, but now it will come disabled, and you can enable if your scenario is this scenario where you might have slow queries taking over space of fast queries in the same pool. If you already have separation and you only have quick queries in one data source and slow queries in another, then you don't need this. But if you have, let's say, a system that it's a mixed level system, this is a very good, very cool feature that you can use. That's what I had prepared, guys, for the presentation. Just before I take more questions, I just would like to ask you to, if you like the project, please give us a star in GitHub, right? Follow us on LinkedIn. It's very important for us to have these numbers growing in stars in LinkedIn, followers stars in GitHub, followers on LinkedIn. Try the project yourself, do a few tests, report any issues you have. It's very important. The people that are reporting issues are helping us a lot because it is helping us to build a more robust version to deploy for production purposes later this year. If you can contribute with the project, it's very cool to contribute to an open source project. If you can give us money, give us money. There is a buy us a coffee in our repository. If you can produce articles or write about it or share it on your networks, that helps a lot as well. People don't realize how much it helps if you just constantly share about an open source project, how much visibility that gives, you know, to the project and to the developers. We have a Discord channel. All this is in our main page. So if you come here to our main page, you can access here. There's our website. The Discord channel is down here, and the LinkedIn page you can access through here as well. That's my X account. If you want to follow me personally, obviously most of my posts are about OJP, but I post about other things as well that I find relevant. So you can follow me as well. Thank you very much, guys. Just one more thing. We have this badge system. So if you contribute to the project, you get these badges, and you see the names of all the people that already contribute to the project. So there is different lanes here. You can contribute code, testing, and quality. You can evangelism and community, so you can advertise the project. You can help with documentation or authoring articles, guides, these kind of things. Every type of work awards badges, and badges have levels, right? So as you contribute more, you grow, and you might become an OJP champion, right? Which gives you a nice certificate and a big place in the Hall of Fame of OJP. That was what I had prepared, guys. Let me just go back to the presentation.
Okay. Can you hear me, Rogelio?
Yeah, I can take more questions if you have more questions there.
Okay. I'm sorry that I disconnected for a moment before. That batch system is very interesting, honestly. I like it very much. I think it's very cool that you are trying to reward people to help in this kind of projects. I really like the open source project and what it represents for the technology community. And make sure to share the project with in the Java Barranquilla group and the ACM student group.
Brilliant, yeah. That's what we need. We need more to reach more people, because every time we reach a group of people, like a Java user group, there's always a few people that get interested and come and help with something. Some people can help more, some people less. But every time you share, like, it's a volunteer project, right? So we depend on volunteers, and we really appreciate all the help. Even today, like organizing this call, again, it's fantastic. Thank you very much for that. And if there's any other questions I can answer, if not, I just would like to show my appreciation for you guys and say that the work you do is amazing. And like, these projects wouldn't exist if groups like this didn't exist.
Yes, we have some more questions to answer, and also for the people that are in the streaming right now watching, we have a contest. We're gonna be giving a key. Or a license for the ID that Rogelio was using in the presentation. So if you stay tuned until the end, you're gonna get a chance to win that. But first, let's answer some questions. The first one: how does the Java app know about the proxy instances? Is it configured in the own app, or it uses something like a discovery server?
It's configured in the app. It's configured in the database URL. So if you have more than one OJP server in the URL where we put just one, right, to localhost, you put more than one then. There is no service discovery yet, but it's something we thought about. It's something that we might implement in the future, if there is a need for that. Because in general, we're not yet sure that there is a need for that, because the proxy, like, there is no proxy that needs that exists today that needs a discovery server. Usually, you know your capacity because you know the capacity of the database, so you know how many proxies you want to put in front of it. So, but it's not the first time we hear about it. We've been talking about this in the community as well. It's an interesting idea, but at the moment it's fixed. So if you put 3 OJP servers as the minimum, you're gonna put the 3 addresses in the connection URL in that OJP prefix, right? Instead of just one, you put 3 IP addresses or DNS names, whatever it is, and then the app will connect to all 3 and load balance between the 3.
Okay. Thank you very much. The next question: is it possible to connect to multiple types of databases simultaneously, or is it limited to one type at a time?
Brilliant. Very good question. You can connect it to as many as you want. That's the beauty of it. So if you for example, if you work in a company that acquired other companies, that merged other companies, it's a very common thing that there is different databases, right? And if you want to use a solution like a proxy, then you need to look at each database, what solution it offers. And with OJP, you don't need to do that. OJP supports multiple databases at the same time with the same server. Like you can deploy, let's say you deploy only one cluster of OJP and you have 2 or 3 different databases, you can connect to all of them through OJP.
Okay. The next question. How does OJP help to create a strategy of growing in distributed architectures?
OJP is a distributed system, right? Like it supports clustering. So what it does is that the client, which is our JDBC driver, knows about all the nodes in the cluster. So the nodes themselves don't need to know about each other. So in terms of how it handles that, we use what we call a client relay system. So we use because we provide the JDBC driver, we rely on the JDBC driver on the application to report which servers it can see. So it can figure it out if one server goes down, for example, and notify the others, and the others will increase their connection pool sizes to account for the OJP server that went down. That's something that also doesn't exist in any other proxies. If you deploy, let's say, a PG bouncer, you're going to have to set a certain amount of connections there, let's say 10. If you have 3 of them and one go down, it goes down to 20 connections. With OJP, because we have a client relay information, we know that one server went down, and we increase temporarily the capacity of the remaining 2 servers to absorb that failure on one of the servers, for whatever reason that might be. And when the server comes back up, let's say Kubernetes provision it again, it goes back then to the same setup as the initial, like 10, 10, 10, if it's a setup like that.
Okay, thank you. The next question is very interesting in the perspective of someone that wants to help in this project. It's from John. He's asking what features are OJP missing and what features are coming next?
Very good question. So the features that are missing, like there's many ideas going around OJP, right? But the features we want to get in before we release a long-term support version is we still don't have a read-write segregation. So some proxies, they support read-write segregation, and that means you can configure the proxy to connect to different nodes of the database, meaning it can connect to the master node of the cluster of the database for writes and to read replicas. And it only sends queries then to read replicas and all the updates to the master node or the primary node of the cluster. So we don't have that yet. We want to implement that before the end of this year. We also don't have caching yet. Like we don't do any sort of caching. So if you execute a query, every time you execute a query, that query hits the database. So we want to offer at least some basic level of caching. So you can configure a few queries to be cached in OJP server. So you don't need to hit the database. For queries that the data don't change frequently, that's useful. We want to do that. Things that are happening right now. Right now we are working on improving observability. So we just merged the tracing capability into the main branch, and we are working on creating better metrics with the open telemetry. We use the open telemetry to export it. So we mainly export currently to Prometheus, but it could, in theory, can be exported to any other collector. And we want to have better metrics. For example, one metric that we don't have and we want to have is the queue depth. So how many connections are waiting for a real connection in OJP server, right? Because if that starts increasing, that's a signal that your system is starting to get under stress. So it's a very important metric we want to get out with a few others, but this one is a core one. Like, what's the queue to get a connection in OJP server? So we're currently working on that. So those are the two main, or the three main sectors we want to get done this year. By the end of this year, we would like them to be implemented before the end of this year, actually around September, October, so we can launch the 1.0.0 version, not beta anymore. And obviously with the feedback of people until there, and fixing any potential bugs, so we have a stable version. We would like to enter 2027 with a production ready version.
Okay, I think that was the last question. So I feel we can continue to the giveaway. So basically, I want you to ask a question to our viewers, and the first one to answer correctly will win. A question about the presentation, of course.
Betsy, I think you're muted if you're speaking.
Oh, hi.
Hello.
Rogelio, did you hear me? Sorry.
I hear you.
Okay, did you hear what I said about the giveaway?
I did hear. Do you want me to make the question?
Yeah. You make a question or your own presentation to test if people were paying attention, basically.
Very good. So the question is, what's the two core differences, or at least two core differences of OJP in relation to any other existing solution of proxies? Two differences that you can remember. Now we wait to see who is faster. Huh?
Si la gente del chat no entendió bien la pregunta, es ¿cuál es la diferencia entre Open J Proxy y cualquier alternativa que haya en el mercado? Las dos diferencias que se pueden acordar, de las que se acuerden.
Es que quedaron 9 personas, no sé si se alcanzan a contestar.
Yeah, very good. Yeah, that's a good difference. Yeah, I think. Yeah, I think John Serpa showed up first for me here.
Ah, bueno.
So you think John is the winner?
Yeah, because there was someone before, but they only mentioned one difference, the centralized control of connection pool. That's correct. It is a difference, but I've asked for two. So to be fair, John Serpa 3782 gave two different differences, right? One that it supports different databases, and it doesn't need a load balancer when you're clustering the proxy. So those are correct answer.
Okay, thank you very much. So congratulations, John. Felicidades, John. Puedes enviar un correo al email de Java Barranquilla que está en el chat, o puedes dejar tu correo en el chat y nosotros te contactamos, como prefieras. And I think that will be it for the giveaway. I don't know if...
Congratulations.
Yes, congratulations. I don't know if Giovanni would like to say something else to finish the talk.
Yes. Rogerio, thank you. Very good.
You can speak in Spanish if you want. I'll understand.
Ah, bueno. No, muchas gracias por participar con nosotros. Un honor para nosotros tenerte acá. Es la segunda charla que damos en inglés. La primera fue en el DJBM 2025. Y pues bueno, ahí vamos como en el grupo, vamos a ir cambiando esa perspectiva para tener más charlas en este idioma.
Ah, importante. Sí, muchas gracias.
Sí, entonces esperamos en otra oportunidad, sea virtual o que nos estés visitando por acá por la ciudad. Seguro que acá sí te va a gustar mucho la cultura, el turismo y la ciudad.
Gracias. Muchas gracias. You as well, if you come to Dublin, si vienes a Dublín, me llama. Confundo un poco el español con el italiano, porque hablo medio el italiano.
Rogerio, yo tenía una pregunta.
Diga.
No sé, Laureano, si me ayudas ahí. Es, si yo quisiera convencer a la organización en la que trabajo de usar OJP, como, ¿qué características o drivers podría iniciar la conversación para que la decisión fuera positiva, como sí, listo, implementemos OGP?
Do you understand?
Sí, respondo en inglés.
Okay.
Me ayuda, Laureano. The first thing I think is the reliability aspect. So when you're selling it, the increase the reliability under stress. That's one big point, right? So if your application is under stress and you don't have this protection on the database may die, and that's a big problem. The second one is most companies are working with an over-provisioned database, and that is cost, right? Costs all year round. So if you're working with an over-provisioned database, putting something like OJP in front of it may allow you to use a smaller database. And if it's a database that requires licenses, maybe it's a cloud managed database, it's a recurring cost. So cost is the second aspect. The third thing I would use is that first to do a POC, right? You never sell this as being like, oh, let's change all our services to this new thing. You suggest, let's do a POC with our most stressed service, and let's do a test with that one. So let's see how it behaves with the most vulnerable service that we have, that we need to scale a lot, and then test OJP with that. Because with those three things, then having data, having acquired knowledge in the team on how to use OJP, and with this increased reliability and the ability to decrease the database you use, I think that's a way to approach, especially management, people that make decisions, and be very assertive to suggest the introduction of OJP. Very good question. That's the first time someone asked me this. Thank you for the question, Betsy. Muchas gracias.
¿Necesitas que traduzcan o estuvo bien? Elizabeth.
Sí, me colocas unos mensajitos.
Perfecto.
Love the mensajitos. I can see them here.
A little
Right,
message.
No, listo, Loreno, ya, sí. Estuvo interesante la charla. Very good, interés. Sí, muchas gracias nuevamente.
Okay, I think that will be all. I'm sorry that I don't have my camera on, but I had some technical difficulties. But anyway, Rogelio, thank you very much for your time and your knowledge and your everything. Thank you for the people that are still here watching this. And stay tuned for more talks and more events for the Barranquilla Java user groups. Good night.
Brilliant. Thank you very much, guys. Really enjoyed being with you. Pleasure to meet you all.
And remember to follow OJP in GitHub. That is very important.
Very important. Very important.
Oh.